Okay, so here are the types of waves, you know. A transverse wave. Transverse means across, so a transverse wave is one where the wave moves up and down. The medium moves up and down, but the wave moves side to side, right? And I can show you a transverse wave here. Ocean waves are transverse waves. Whenever anybody draws a wave, they always draw a transverse wave. And the reason for this is that it's, well, you'll see when you see a longitudinal wave, it's very hard to draw. So here are transverse wave pulses I'm sending down. Okay, the wave pulse is moving that way, right? But the medium is moving up and down. Okay, the next kind of wave, and I've got a little applet that can demonstrate this. The next kind of wave is a longitudinal wave. These are really hard to draw because to make a transverse wave pulse, I just move the medium across, or transverse, yes? This is kind of obvious, right? So there's a transverse wave pulse, right? To make a longitudinal wave pulse, I have to take the medium and compress it and then release it. Did you see that? That's very hard to see, isn't it? Right? In fact, the only thing you can see really is there's a little bit of a transverse part to it. So what I'm going to do is I'm going to put a little thing in there. I'm going to put a little thing in here. I'm just going to go kind of like this and kind of a little thing. I'm just going to fold the paper and do a little thing. Right? Just kind of do a little thing like that. You must pay the rent. I can't pay the rent. You must pay the rent. I'll pay the rent. My hero. Curses foiled again. Okay. What? What just happened? Did I do a thing? I did the thing, didn't I? I did the thing. Dang it. Okay. Don't know where it's from. Don't know where it's from. Okay, anyway. Stevie's just looking at me like, you really are crazy. You're just figuring that out. Okay. Thank you for noticing. I am crazy. Okay, here we go. So I'm going to send this guy through here. And what you're going to do, actually, I'll put it like a little farther on down. Okay. We'll put that in there. And what you're going to see is when I send the pulse through, you'll see the little thing go side to side. Watch. It's like, you see it going, isn't that kind of cool? It's like, listen, it makes a cool sound too. So you hear the little, that's the sound they use in Star Wars to make the blaster sound, right? Yeah. Part of it. They added stuff to it. And then, of course, the thing fell out because when a longitudinal pulse goes through, there's a compression, and then there's also something called a rarefaction where it's like spread apart. And when the spread apart thing went by it, it fell out. A little applause for the bow tie. There we have it. All right. Hey, I'm back. All right. Sorry about that. Okay. And then we've got, I've got an applet. Let's see if this link works. Oh, run this time. Right? So this is a transverse wave. I already showed you this guy, right? And that's kind of cool. I'm going to stop this animation and let's go back. I'm going to run the longitudinal wave one. This one, for longitudinal, the motion is along the direction of, right? So if the velocity is this way, the medium moves back and forth. It turns out sound is a longitudinal wave. So when you beat on the head of a drum, the drum moves in and out. It makes compressions and also rarefactions, places where the pressure is higher and lower than the regular air pressure. But this is the best demo of it. You can't draw a picture of this, but there it is. Let's see amplitude. Let's make the amplitude a little bit less. There we go. Okay. So there it is. You can see that the compression is what moves down. This is a brilliant thing because a longitudinal wave, right, is very hard to draw. And this is why nobody draws them, right? Because how do you draw that? You know, I don't know. Good luck in your notes. You know, but that's what's going on. If these were air particles that somehow were like, you know, held in exactly the right position or something like that, right? If you beat on the head of the drum is just moving in and out. The drum head is moving in and out, and the sound is doing the same thing, right? So to make sound, what you do is I need a dead battery, okay? So you take a dead battery. This is a speaker. Please be nice to my speaker. I'll pass this around. Don't try to make the most annoying sound possible with it, but do try this, okay? You hook it up like this, and you'll see the speaker will move in, and then if you hook it the other way, it'll move out, okay? It excerts, which is to move out, and it also incurts, which is to move in. I just made that word up, right? It should be a word, like excursion, right? Incursion is also a word, right? But incurt is not a word. Why not? It's like a missing word, right? Okay. Anyway, I'll pass this around, and this is going to make sound. Obviously, if we sent a frequency of sound that we could hear in there, it would move back and forth and make little waves like this, longitudinal waves. Because a battery of regular strength might burn out the coil inside there, but a dead battery's got enough juice to sort of, you know. It's like your dead batteries from your digital camera can still run your headlamp for a long time. That's an interesting thing. So you can kind of reuse them that way. I'm going to stop this animation because Java makes us a little sluggish here. So there's transverse waves and there's longitudinal, right? Right? Transverse, the wave moves that way, but the motion of the wave is up and down, right? Because it's across, like Trans-American. Yeah? Yes? The Trans-American Railway, right? Or a Trans Am is like a car that could drive across America. That failed, didn't it? I don't know, right? Okay. And then longitudinal, the motion is along, right? So if the wave's moving this way, the medium is just moving back and forth like that, right? Could you have a longitudinal, could you have a transverse wave travel through air? Think about this. Can I grab the air between Sean and me and go, take the air and go, and have a wave of air go to him? Now it only works for objects that remember their shape, right? So it'll work for the surface of a fluid, right? It'll work for the spring. It'll work for like the crust of the earth, a steel rod, something that remembers its shape. But fluids, it can't go through the center of a fluid. Only longitudinal waves can go through something that doesn't remember its shape, which is sort of.
So like longitudinal waves, those work in the ocean?
You can go through, longitudinal waves can go through the water of the ocean, deep in the ocean. So like tsunami waves are actually longitudinal waves that travel under the surface, right? Along the surface, of course, transverse waves work because this ocean surface remembers its shape. It should be flat, right? And so they...
What type of wave would be like electromagnetic wave?
Well, electromagnetic waves are actually transverse. Isn't that crazy? So as the wave travels this way, if the wave is traveling this way, the electric field is this way, and the magnetic field is this way. Right? So it's actually got two components to an electric field and a magnetic field, and they're at right angles to each other. And both of those are perpendicular to the direction of velocity. Yeah? That's crazy. Okay, let's all go out into the hall, and if we could have Travis, if you'd grab this camera here, and we'll go outside and we'll do this. You could be my... You don't need to press any buttons, it's already recording. But you could just sort of film. Let's go out and line up in front of the principal's office. That's tough.
How's that still recording? Tough. You took 4 days off from math? 3 days.